Hello everyone, my name is Durgesh Sirsat, and the topic of presentation is barometers, measuring atmospheric pressure. Barometers play a crucial role in our understanding of atmospheric pressure and its impact on weather forecasting, aviation, and climate science. Their evolution from simple mercury tubes to sophisticated digital instruments mirrors humanity's relentless pursuit of knowledge and technological innovation. Understanding barometers not only deepens our appreciation for science but also connects us to the environment and the forces shaping our daily lives. Hence, the topic barometers was chosen to spotlight their historical significance, technical evaluation, and wide ranging applications. Welcome to the presentation. Barometers are remarkable instruments that have shaped our understanding of atmospheric science and its many applications. Through this presentation, we will uncover the history, evolution, and significance of barometers in weather forecasting, scientific research, and everyday life. Barometers have a rich history dating back to the 17th century. In 1643, Evangelista Torricelli invented the mercury barometer in Florence, Italy. His innovative design, a glass tube filled with mercury inverted into a basin, was the first instrument to demonstrate the concept of atmospheric pressure. Later, in 1648, Blaise Pascal conducted experiments with Torricelli's invention. He took the barometer to higher altitudes and observed a decrease in pressure, proving that atmospheric pressure varies with elevation. Pascal's work was instrumental in connecting barometric readings to altitude and weather conditions. The next major advancement came in 1844 when Lucien Vidi developed an aneroid barometer. Unlike the mercury barometer, the design used a sealed metal chamber that expanded and contracted with changes in pressure. This innovation made barometers portable and accessible for everyday use. Barometers come in three main types: mercury, aneroid, and digital. Mercury barometers are highly accurate but contain toxic mercury, which limits their usage. Aneroid barometers utilize a flexible metal chamber. Air pressure changes cause the chamber to expand or contract. They are portable and mercury free. Digital barometers utilize advanced sensors to provide quick and precise pressure readings, often integrated into devices like smartphones. Each type has unique advantages suited to different needs. Let's explore the working mechanisms of these instruments. A mercury barometer relies on atmospheric pressure pushing on a mercury reservoir, causing the mercury to rise or fall in a glass tube. This indicates pressure changes in pressure. Higher pressure equals to higher mercury level. An aneroid barometer uses the sealed, flexible metal chamber. Pressure changes cause the chamber to expand or contract, with these movements reflected on a dial. Digital barometers use electronic sensors to detect pressure changes, converting them into digital readings. They are modern, user friendly, and precise. Atmospheric pressure is measured using various units, including atmospheres or ATM, millimeters of mercury or mmHg, inches of mercury, that is INHg, hectopascals, short form for HPA. 1 atmosphere equals to 760 mmHg or 1013.25 hectopascals, providing a standard for global pressure measurements. Atmospheric pressure decreases as altitude increases because fewer air molecules are preventable. This explains why mountaineers carry oxygen tanks at extreme altitudes. Weather also influences pressure. Low pressure often signals storms, while high pressure indicates clear skies. Diurnal variations caused by daily temperature changes lead to slight pressure fluctuations. Barometers are vital for weather forecasting. Meteorologists analyze pressure trends to predict weather patterns. Falling pressure often indicates approaching storms, while rising pressure suggests improving conditions. Isobars or lines of equal pressure on weather maps help identify high and low pressure systems, improving forecast accuracy. Barometric readings are combined with satellite and radar data. This comprehensive approach improves forecast accuracy. Barometers are crucial in aviation, where barometric altimeters help determine aircraft altitude. Pilot must adjust these instruments to account for local pressure changes during flight. In maritime operations, barometers help predict storms. Sudden pressure drops can signal dangerous weather, ensuring the safety of ships and crews. Barometers contribute significantly to science research. In climate studies, long-term pressure data helps track climate patterns. This aids in understanding global atmospheric circulations. In geological research, precise barometers detect minute pressure changes. This can indicate seismic activity or volcanic unrest. Atmospheric science. Barometers help study atmospheric waves and oscillations. This improves our understanding of global weather patterns. In environmental monitoring, barometers are used in air quality studies. They help correlate pollution levels with the atmospheric conditions. Barometric data plays a key role in climate change research. By analyzing decades of pressure patterns, scientists can identify shifts in weather systems. This data also tracks the frequency of extreme weather events, providing vital evidence of climate change. Barometers providing long-term pressure data. This contributes to climate models and trend analysis. Researchers study pressure patterns over decades. These patterns reveal shifts in global weather systems. Barometric data helps track increasing frequency of extreme weather. This supports climate change evidence. Parameters have become part of our daily life, appearing in smartphones, smartwatches, and smart homes. They are used for fitness tracking, weather alerts, and optimizing home HVAC systems. Vehicles also use barometers to manage engines and improve climate control. The innovation timeline of barometers highlights key milestones. In 1643, Torricelli invents the mercury barometer. In 1844, Vithi creates the aneroid barometer. In 1960s, electronic barometers become compact and precise. In 2010s, microelectromechanical systems barometers are integrated into smartphones and wearables. Barometers differ from other weather tools like thermometers and hygrometers. Barometers measure atmospheric pressure, predict short-term weather changes, essential for forecasting storms and pressure systems. On the other hand, hygrometers measure humidity levels in the air, effort for comfort and mold prevention using greenhouses and industrial processes, while thermometers measure temperature, crucial for daily weather reports used in various scientific and medical applications. Common barometer issues include sticky needles, inaccurate readings, and condensation. Regular calibration and cleaning and maintenance help ensure accurate results. For digital barometer, checking batteries and connection is essential. If there is a sticky needle, gently tap the barometer case. If the needle doesn't move, professional cleaning might be necessary. If there is a problem in inaccurate readings, compare with the official weather reports. Recalibrate if discrepancies persist. If there is a problem of condensation, place the barometer in a dynamo or use silica gel packets to absorb the moisture. If there is a problem with the digital display, then check the battery as I said before or connections. Consult the manual for reset procedures. Proper calibration is critical. Start by comparing your barometer reading with a known standard. Regular checks, cleaning, and annual professional service keep the instrument in top condition. Initial calibration is the must. Compare barometer readings to a known standard. Adjust the instrument to match the reference value. Regular checks are also necessary. Perform monthly comparisons with official weather stations. Note any discrepancies for recalibration. Cleaning is also necessary. Gently clean the barometer's exterior. For mercury barometer especially, carefully inspect the glass tube. There might be a need of professional service too. Schedule annual professional maintenance. Address any issues promptly to ensure accurate readings. Parameters have distinct advantages, like they provide crucial data for weather forecasting, essential for aviation and maritime safety, aid in scientific research across multiple fields. Modern versions offer high precision and portability. But, however, limitations include toxicity of mercury, of course, in the mercury barometers. Android barometers require regular calibration. Digital barometers depend on power sources. so they are expensive. Local factors can affect readings, requiring interpretation. Barometers are vital for predicting extreme weather. Sudden pressure drops warn of hurricanes. If barometers detect rapid pressure drops indicating an approaching hurricane, this provides crucial early warnings. Also, if sudden localized pressure changes is there, then there is a case of tornado. Mobile barometer assist storm chasers. Barometric pressure trends help forecast winter storm. This aids in emergency preparedness planning. Barometer pressure maps use isobars to depict high and low pressure systems. Closely spaced isobars indicate strong winds. Pressure systems marked with H for high and L for low, and key for interpreting weather trends. Lines with symbol indicate weather fronts. These show boundaries between air masses. Atmospheric pressure systems are critical for understanding weather patterns and forecasting. High pressure systems, often called anticyclones, bring clear, calm weather. These systems are associated with descending air that compresses and warms, dissipating clouds and promoting sunshine. Winds in high pressure systems move clockwise in the northern hemisphere due to the Coriolis effect. In contrast, low pressure systems or cyclones are linked to cloudy and stormy weather. Here, air rises and cools, leading to cloud formation and precipitation. Winds in these systems move counterclockwise in the northern hemisphere. One fascinating aspect in the interaction between pressure systems, for example, when a high pressure system meets a low pressure system, the resulting gradients cause strong winds and shifts in weather patterns. The spacing of isobars or lines of equal pressure also provide clues. Closely spaced isobars signify strong winds, while widely spaced ones indicate calmer conditions. Understanding these dynamics is crucial for weather forecasting and managing activities affected by atmospheric conditions. To conclude, barometers are not just analytical instruments, they are windows into the invincible forces shaping our world. By measuring atmospheric pressure, barometers have enabled humanity to predict weather, ensure safety in aviation and maritime operations, and contribute to groundbreaking scientific discoveries. From Torricelli's mercury barometer in 1643 to modern digital barometers integrated into smartphones, these tools have evolved to meet the demands of science and daily life. Their application spans numerous fields: weather forecasting, climate change research, extreme weather prediction, and even personal fitness tracking. As we are explored, each type of barometer, mercury, Android, and digital, has unique features and benefits, making them versatile and indispensable. Despite their limitations, barometers remain at the heart of atmospheric science and environmental monitoring. In essence, barometers represent a perfect fusion of history, science, and technology, reminding us of our ability to understand and adapt to the natural world. For those who wish to deeper into the fascinating world of barometers, here are some recommended resources. The Barometer Handbook by David Burch is an excellent guide for enthusiasts and professionals alike. It covers the history, types, and applications of barometers in detail. Weather prediction by numerous process by Lewis Richardson offer insights into the broader field of meteorology and the role of barometric pressure. Explore the National Weather Service website for reliable and updated information on barometric pressure and weather forecasting. METED, a platform for meteorology education, offers free courses tailored to all levels to expertise. Many regional meteorological societies conduct workshops and provide access to barometric data, which can be a great way to connect with scientific community. These resources not only expand your knowledge but also provide practical insights into the application of barometers in various fields. In wrapping up, barometers are more than instruments for measuring atmospheric pressure. They are tools of exploration, safety, and discovery. They bridge the gap between the invincible forces of nature and our understanding of them. We have journeyed through their invention, education, and modern application, highlighting their importance in weather forecasting, environmental monitoring, and scientific research. By mastering the science of barometers, we gain a deeper appreciation of the dynamic atmosphere that shapes our lives. Thank you for joining this presentation. I hope it has inspired you to view barometers not just an analytical instrument but as symbols of human curiosity and innovation.